Okay, all right, everyone. Hello, everyone. My name is Gavin. I'm currently an assistant professor at UT Dallas. The paper I'd like to present today is AI exposure on workers' career path, evidence from U.S. workforce. It's joint work with Guohou Shan from Northeastern University and also Amit Mehra from UT Dallas. So the motivation of this paper is recently we have seen a lot of research showing that AI has been replacing human jobs, right? But a natural question is whether human will really necessarily become worse off. The point is that although AI has been replacing human jobs, but we also know that human will adapt to changes, right? Before there were motor vehicles, people were riding horses, but after there are motor vehicles, you cannot say humans are necessarily worse off because now they have to drive cars, okay? So in this paper, we're actually trying to figure out whether human will be worse off or better off after their working environment is exposed to AI. Because you cannot say having a calculator will necessarily make you worse off, okay? So the research question in this paper is, how does being exposed to AI affect the career path of employees? We're gonna examine whether these employees are getting better off or worse off in the long run. And we're also gonna examine who will benefit more from being exposed to AI and why is that, okay? So in order to conduct this study, we have compiled multiple data sources. We have got all the publicly traded firms in the United States in the manufacturing sector, which gives us about 3,000 companies. The reason we're looking at manufacturing companies is because it is one of the largest sector in the United States. And also more importantly, most manufacturing companies, they are companies that use AI, but they are not producing AI. So in this way, we can guarantee that the employees in these companies are exposed to AI when they're in the company, instead of, for example, they have been exposed to AI before they join this company. And we also use the burning glass technology data, and we have already learned the pros and cons for using this data to measure the technology capabilities. So here we have obtained all the job titles and salaries for each job posting, and also with detailed description, including the required skills. In this way, we can identify whether the company has started to adopt AI. Furthermore, we have used this Revalue Labs data, which is basically the LinkedIn resumes. According to the company, this data set has covered over 80% of the total US workforce. So we have obtained all the education background and also full career trajectory with their job titles and salary for each individual employee affiliated to all the companies in our sample. And by merging all the data sets together, we are able to get about 1 million employees in the United States from 2010 to 2024, and we construct a panel data on the employee year level, okay? And in order to measure the AI exposure, we're actually using a binary indicator, which is the year when the employee's firm first posted an AI job. So we're using the burning glass job posting to identify when the company has first posted an AI-related job. And we're basically following the previous literature to use the keywords about AI to document whether this company is posting an AI-related job. And this is a staggered exposure, which means that once a person is exposed to AI in a company, this person is forever exposed. Like even afterwards, for example, the person has hopped into some other companies, this person is still exposed to AI. And we also try to change this binary indicator into a continuous variable by using the cumulative number of AI job postings for the company. And the results are pretty much consistent in our main findings. And in order to measure the individual employee's future performance, we have used two main indicators. The first one is their future salary, okay? So basically, we're using the salary of the same individual employee that is 3 years or 5 years after this person is exposed to AI. And this salary data is actually predicted by Revalue Labs based on the large-scale job data that they obtain. And we also cross-validated this data set using the burning glass job posting data, because from the job posting, we can also take a look at the salary for each job title in each company so that we can cross-validate the data provided by Revalue Labs, and they are pretty much consistent. Furthermore, we also measure employees' future seniority level using the data provided by Revalue Labs. So basically, Revalue Labs has classified all their employees into 7 seniority levels, from the entry level, for example, accounting intern, software engineer trainee or paralegal, all the way to junior level, associate level, manager level, and executive, senior executive levels. So there are 7 levels in total. And in this way, we can also take a look whether these employees get promoted more in 3 years or 5 years after they're exposed to AI. And there are 7 levels in total. The classification is based on the job postings. Okay? So with this data, we're able to take a look at whether, the employee's salary or seniority level will going to be increasing or decreasing in the future. And basically, this is a very straightforward panel model, and we have added a bunch of control variables, including the fixed effects of individuals and companies. We also add a bunch of control variables for the individual performance at the time of the panel data, and also the company performance indicators. And for the identification strategy, the first thing is, for individual employees, being exposed to AI is usually exogenous to their personal decision, especially if you are a junior employee in a relatively lower rank. Okay? So in this way, being exposed, like the company's decision to use AI is really out of your decision. However, there might be concern that, for example, if you're a higher level employee, you might also get involved into the decision of the company to adopt AI. So in this way, we also created 2 matched control sample for the employees. So the first matched control group are those employees who graduated from the same school, same major in the same year. But for these 2 employees, one of them actually gets exposed to AI maybe earlier than the other, so that we can compare their job trajectories to take a look at whether being exposed to AI has an impact on this person's future career. And the second match control group are employees who left the firm right before the exposure year. So we use a 2-year window here. Basically, it says that, for example, if the company has adopted AI in 2015, then we assume that those employees who left the company in 2014 are almost the same quality as other employees remaining in the company, but because they just left the company before 2015, so that they are getting exposed to AI in a later time, so that we can also use them as a control group. Besides that, we also use some exogenous shock to the firms adopting AI. So here we're also using a Hausman-type instrumental variable. Basically, we're using the AI adoption of firms from which the focal firm hire people from. Okay? The logic here is that, so for other companies who are actually our focal company hire people from, if those companies are adopting AI, then very likely our focal company will also adopt AI. But other companies' hiring decision should not directly impact the performance of individual employees in our focal company. Okay? So these are the identification methods we used for this paper. And let me show you the main results. So for the overall results, we actually find out that after being exposed to AI, your future salary and your future seniority will be increasing. Okay? Seems like everybody is getting happy. However, we also document a level bias technological change. Basically, we find out that if you take a look at the interaction effect between AI exposure and the individual employee's current seniority, the interaction term here is significantly positive. However, I should highlight here that we actually standardize this measurement of current seniority so that this value would vary from negative to positive. Okay? So in this way, if you take a look at this marginal effect of AI exposure on individuals' future outcome, it's actually the coefficient number 1 plus coefficient number 3 times your seniority level. And because we have d-mean this seniority level, it means that there's actually a cutoff point. If you're below this level of seniority, your future will be worse off. But if you're above this seniority level, your future will be better off. Okay? So basically, our results show that for higher level individuals, so basically those people who are above level 2, your future will be better off after being exposed to AI. But for lower level individuals, for those with level 1, level 2, your future will get worse off. Okay? So if you're a tenured full professor, congratulations. But if you're a PhD student, I'm sorry. Okay? So we also find out that this is not actually driven by your length of experience. We also control, the number of years this person has been working, and the results are still pretty consistent. So it's not driven by the length of one's personal experience. And in this paper, we try to provide a potential explanation for this. The reason is that higher level employees usually possess more domain knowledge. And we also know that as a prediction tool, AI complements domain knowledge. So that explains why more senior employees get better off. But for lower level individuals, AI can actually hinder their acquisition of domain knowledge. So this is the process called shadow learning. Basically, shadow learning was proposed by Matt Bean in this paper. He finds out that after hospitals have adopted robots to help with surgeons, he finds out that the surgical learning practice will actually, so the learning process will increase in the traditional approved method. But actually, if the individual surgeons are learning with robots, they're actually learning in a much slower way. So basically, with AI in the workplace, the use of AI can limit the junior people's role in their work and also reduce their training. And also the black box nature of AI makes it more difficult for lower level employees to understand the decision-making process, so that it's making them harder to pick up the domain knowledge. So we also try to verify this mechanism by measuring one's domain knowledge using the certificates one posted on LinkedIn. Okay, because we also have the accurate issuance time for each certificate. And so in this way, we're able to see that after being exposed to AI, actually AI exposure has a negative impact on the number of certificates one employee can obtain. And this effect might be not that serious for people who are of higher seniority level. But for junior people, this effect is actually even worse. Okay, so basically we find out that AI exposure hinders domain knowledge acquisition, especially worse for junior employees. However, if you take a look at the complementarity effect between domain knowledge with AI exposure, it's actually significantly positive, showing that AI is pretty complementary to the domain knowledge possessed by individuals. Okay, so let me summarize. So in this paper, we document a level bias technological change showing that higher level employees get better off while lower level get worse off after being exposed to AI. And we find out there is a divergent effect of AI on domain knowledge. So for individuals with more domain knowledge, AI can further augment the benefit. But for those without domain knowledge, AI can actually hinder your acquisition of domain knowledge. And there's a lot of implications for organization, policymaker, and education institutions, because the first thing is we can see a labor market polarization because of this effect. And as universities, we probably need to think more about how to cultivate our students. Because nowadays, if we are just sending rookie students into the job market, they're actually taking longer time to pick up the domain knowledge in the workforce. So the key takeaway of this paper is that having a calculator will not necessarily make you worse off unless you are too young. Okay? Thank you. Yes, please.
So with respect to your summary and discussion points, is this specifically to the manufacturing industry?
So basically in this paper, our main sample are companies in the manufacturing sector. But we also replicate our results using all the public firms in the United States, and the results are also consistent. The reason we're using this sample here is to, we try to focus on companies that are, using AI but not producing AI, so that the results are cleaner.
Okay. Follow-up question, if I may. So when I understand the deviation, right? It makes sense that people in a higher position benefit and people in a lower position are worse off. That makes sense. Over time, though, in theory, right, if we believe in progression of careers, the people in the lower levels eventually become senior directors and maybe CFOs, right? So how does this pattern play out in the longevity of a career or within a company? If you're trying to get your interns to stay in the company over 20 years, what does this pattern say about career projection?
I think this is a very good point. I think due to data limitation, because AI is a relatively new thing. So in this paper, we're only able to take a look at from 2010 to 2024. So it's like largely about 10 years of span at most. Probably if we get a longer period of time, we can also take a look at like long-term career trajectories. But I think based on our what we find out, so the main findings of this paper is actually not just looking at the individual's future career trajectory, but we're basically comparing this individual to another counterfactual individual who works in a company without AI. So in comparison to that person, you're getting worse off. Okay, so if that person, for example, in a no AI company, that person is, for example, even getting worse off, then you're getting, much worse off than you used to be. So this is kind of a, comparison result instead of, a pure trajectory for the employees. Yes. Yes, please.
Are you able to disentangle this from digitization? Because it's very early in the actual uptake of AI in the manufacturing sector.
Right.
We have evidence of similar effects just in firms that become more digital. It'd be very interesting to make sure this is not
That's a yes.
broader digitization push.
Right.
As opposed to AI specific.
That's a very good point. So actually, one thing we have done before is we're actually substituting all the AI keywords using IT keywords, and the results not there. So I think firstly, like based on all the traditional IT literature, there is a skill bias technological change, right? People with more IT skill, they'll get better off. However, in this one, like for our findings, it's actually totally different from the traditional IT-related skill bias technological change, because we find out that this one is actually related to your domain, specialized knowledge in your specific area or in your domain. So that's actually a very different story from the IT or digitalization story. Sure. Happy to talk offline. Daniel.
So, the assumptions all hold and you've got a causal effect. It's causal for the changed equilibrium. But I'm curious underneath that all in the labor market, is this supply, is it demand, is it some mixture? I think two people with similar starting points, one goes to an AI-enabled firm, they've got to think some of that selection, right?
Right.
How should we think about that?
That's a very good point. So actually, one reason we're looking at manufacturing industry is I feel like this industry is relatively more mature in comparison to like some emerging areas, like for example, AI or information technology. So because this industry is more mature, so I believe the market equilibrium in this domain would also work better. So it's more likely that when certain things happen, the market will quickly adjust to this, this kind of new things happening. So actually, this is one of the reasons we're looking at this. But I mean, another point goes to kind of identification of the results. I totally agree with that. I mean, there's probably no way for us to get perfect identification in this setting. But I believe that because we have used a bunch of control and also the matching methods and also the instrumental variables. So we try to make it less serious as a problem here. Yes. One more question? Yeah, please.
Are there any practical insights to avoid the shadow learning happening while still ensuring AI tools can be accessible?
Try to get promoted to full professor as soon as possible. So yeah, for other questions, I'm happy to discuss offline. Okay, thank you. Thanks.